Hopefully you've had an opportunity to try these problems. I'm now going to walk through the solutions for them. So first we're going to determine the oxidation state of each of these molecules that are listed for each of the elements within it. So we're really going through our list of rules. So it might be handy to have those with you as I walk through this. So first we're looking at water. There's no metals to worry about. It has an overall neutral charge, so it's going to have to add up to 0, whatever oxidation states we assign. And so for this one, going through my priority list of nonmetals, hydrogen is first. So our hydrogen is going to be +1. Now, our rule says that oxygen will be -2, but because it's the last element left, I'm actually going to figure out what its oxidation state is just from the charges of hydrogen and the fact that everything has to equal 0. Or sorry, the oxidation states of hydrogen and the fact that everything needs to equal 0. So I have 2 hydrogens at +1 each. So that's an overall +2 oxidation state coming from the hydrogens. So to balance that out, I need a -2 on the hydrogen to equal 0. So the oxygen will be -2. All right, let's look at the next one. It's H2. Now, this requires recognizing that hydrogen in its elemental state is diatomic. So that means we're looking at elemental hydrogen right here. So its overall oxidation state for both of those atoms will be 0. Next up, we have carbonic acid. So again, we don't have a metal, so we're just going to walk through our non-metal priority list. And it's going to start with fluorine. We don't have any fluorine. So next we'll look at hydrogen. We have 2 of those, so they'll each be +1. Next, we'll assign oxygen. It's next in priority underneath hydrogen. So these will all be -2. So then looking at this, that means we're going to have 2 hydrogens at +1 for their oxidation state. And we're going to have 3 oxygens at -2 each. So that's -6. So that's going to give us overall -4 oxidation state so far. And we need this to equal 0 because it's a neutral molecule. So that means to make this equal 0, this X needs to be +4. So that makes the oxidation state of the carbon +4. Last one, iron bromide. All right, well, so in this case, iron is not a group 1 element. It's not a group 2 element. It's not a standalone ion either. However, we do see this as an ionic compound. And so kind of the shortcut to this, there's kind of 2 ways to think about it. You can either go through all the rules and say, well, the last rule is like we can get to halogens are going to be -1. And I have 2 of those. So that makes my iron +2. But for these ionic compounds where we have 2 monoatomic ions, then we can just decide what the oxidation state is based on the charge. And so if this were to break up into a solution, we would have iron +2 and 2 bromines that were -1. And so these charges for these monoatomic ions are going to be the same charge as oxidation state. So I'll say my oxidation state of iron is +2, and my oxidation state for my bromine atoms are -1. All right, last one. Let's look at identifying which species is being reduced and which one is being oxidized. So I'm going to go through and first assign all my oxidation states. That's always step 1 in these problems. Now my arsenic is a solid and it has no charge, so we're looking at an element. So it's going to have an oxidation state of 0. I'm looking at my chlorine next, and it's diatomic chlorine gas, which is the elemental state of chlorine. So it's also, both of those atoms have oxidation state of 0. So far, so easy. All right, so now we're going to look at arsenic chloride. Now, arsenic is a metalloid and chlorine is a nonmetal. So I'm not going to treat this as an ionic compound. Instead, I'm going to continue to go through my rules and apply these based on the group number. So I'm all the way down in kind of that rule set around just our nonmetals. And I'm always going to look at that group 3 last in my priority. And so the chlorine is a halogen. It comes up 1 priority level before the arsenic. So I'm going to assign an oxidation state to the chlorine first. I'm going to make these all -1. And then I'm going to determine what the arsenic is based on the chlorine. So I see that this has an overall neutral charge of 0. And so if I have 3 -1 charges for my chlorine, I'm at a -3 total for my oxidation states. And so my arsenic is going to need to be a +3 to balance that out. So my arsenic will be a +3 oxidation state. So now that I have these assigned, I'm going to focus in on each element and see what's happening. So my arsenic is going from 0 to +3. So that's getting more positive in charge. That tells me we're losing electrons. If we're losing electrons, then we're being oxidized. Then we look at chlorine. I'm going from a 0 to a -1. Now that's becoming more negative, so it's gaining electrons. So it's being reduced. All right, so my arsenic is oxidized or is the reducing agent. And my chlorine is reduced or it's acting as the oxidizing agent. If I wanted to write the half reactions for these, the way I would do it is I would focus first on arsenic. And this is really going to arsenic +3 for the oxidation state in my arsenic chloride. And so that's going to, and I'm not going to break these up ions because like these aren't ions, right? Like I did with the metals. And so I'm going to add to that, to balance out that +3, I'm going to need 3 electrons that are produced as it's oxidized. And now for my chlorine gas, I'm going to add to that. It's going to go to arsenic Cl3, which is -1. And so I'm going to need to add electrons to that. So there's 2 of these and 2 of these, sorry. So if we wanted to balance out our electrons, we would make sure that we used, instead of 3 electrons, 6 electrons with the arsenic, since we have 2 arsenics going to 2 arsenic chlorides. And here we have 3 chlorine molecules going to 2 arsenic chlorides. And so the number of electrons that are going to transfer in this, going from 6 chlorines at 0 to 6 chlorines at -1, would be 6 electrons. And those would be my half reactions. On the top, I have my oxidation half reaction, and on the bottom, I have my reduction half reaction.